radicals. Well, we're going to simplify all the radicals. They have to have the same index, which means they're both like squared or cubed, etc. And they have to have the same radicand. It means on the inside it has to be the same. And then you can combine. So for common radicals, you add and subtract the coefficients of the numbers out front and keep the common radicals. So just like what we did with variables, I have 2a plus 3a and 5a. I just add the coefficients and keep the variable. So here, I'm going to break it down first. So 4 times 5. Square root of 4 is 2. So on the outside, I'm going to end up negative 4 radical 5 times 2 radical 5. Now, they have the same radicand. So negative 4 minus 2 is 6 radical 5. Combining like terms. Again, I'm going to do the odds in calculus and the evens. So on this one, they both have the same radical 6. So 3 of them take away 2 of them gives me 1 radical 6. Or you could just write it as radical 6. This has a radical 7. Let's see if I can get it to a radical 7. So 7 would be times 9. The square root of 9 is 3. So I've got 10 radical 7. This would give me, multiply that out, so positive 6 radical 7. That's 16 radical 7. Number 5, we got 18 and 32. They both break down because 32 breaks down to 16 times 2 and 18 breaks down to 2 times 2. So the square root of 16 is 4. The square root of 9 is 3. And we multiply things together out here. So I end up with 8 radical 2 minus 9 radical 2 is negative 9 radical 2 or negative radical 2. However you want to write it. Either one is fine. These both end in a 0, so let's go ahead and take it 16 times 10. The square root of 16 is 4. So this would be negative 16 radical 10. The 9 over here, 90, would be 9 10. The square root of 9 is 3. So negative 2 times 3 is 6 radical 10. Now they have the same index, yes, and they have the same radicands. So negative 16 and negative 6 of them gives me negative 22 radical 10. Here's some more. Now we're going to have 3 items. So that radical 10s and radical 6s. 10s break down 2 and 5. There are no perfect squares in it. So let's go ahead. These two are like terms. And I get 4 radical 10. And this one's separate. So I'm going to bring him down all by himself. And we're done. 11's not quite as easy as that. This one's already broken down to a prime, 3. But 18 can be broken down to 9 times 2. Square root of 9 is 3. Positive 3 radical 2. And this is negative 3 radical 3. This one over here, let's break it down and use black. Just 25 times 2. The square root of 25 is 5. So I'm going to get negative 3 times 5 would be negative 15 radical 2. Now, radical 2's and radical 2's are going to go together. So I get negative 12 radical 2 minus the 3 radical 3. Okay, we have 13, 15. I think that's almost it. Then we get into application problems. So I have 8. Hopefully you know by now that's 2 radical 2. Should be memorized by now. So it's negative 10 radical 2. The middle one, 45. Hopefully you know it's 9 and 5. Square root of 9 is 3. So 2 times 3 would be 6 radical 5. Now 200, the largest perfect square of 200 is 100. So 2. Square root of 100 is 10. So 10 times 3 is positive 30 radical 2. As I look at this, I've got common radical 2's. So negative 10 plus 30 would be 20 radical 2 plus 6 radical 5. So one more like this. I got negative radical 5, negative radical 5, and a negative 2 radical 5. And this is like a negative 1 radical 5. So negative 1, and negative 2. That's going to give me 1, 2, 3, 4. Negative 4 radical 5 plus 3 radical 7. Then we have writing the perimeter of a triangle. So basically, perimeter of a triangle, we're going to add up all the sides. So side 1 plus side 2, 3 equals the perimeter. So I'm going to say 2 radical 72 plus 8 radical 18 plus 16 radical 2. And breaking down. 9 times 8. Oh, I could go actually a little bit more than that. 72 breaks down to 30. Oops. 36. And the square root of 36 is 6. That gives me 12 radical 2. 18 breaks down to 9 times 2. 49 is 3. So that gives me positive 24 radical 2. And over here we have 16. That's already done. So it's going to down 16 radical 2 because it is as it is. Now, radical 2s, and radical 2. So they can all be added together. 12, 24, and 16. Well, so that gives me 10, 12, here the 1, 2, 3, 4, 5. 52. So I get 52 radical 2, and it would be units. It's just perimeter. Then, here I'm asking you to represent the perimeter of the rectangle in simplest radical form. Length and width represented by these. So basically, if I were to draw this and say it's length and width, 2 radical 405, and this is 9 radical 48. Well, great. Perimeter would be another one of these would be the same. So 2 of the 2 radical 405 plus, and I want 2 of these as well, right? So 2 times both of them, so 9 radical 48. So once I get to here, I can do a couple things. I can either distribute and then add them, or I could go ahead and break it down and then put it to the very end. So 405, I know it is about 5, but let's see. It goes in there 8 times and 1 time. So the square root of 81 is 9. So and now I have 2, and it's 18 radical 5 plus 48 breaks down to 6 times 3, and the square root of 16 is 4. So plus 36 radical 3. Now do your distributive property. And I'm going to end up with 36 radical 5 plus 32 radical 3. So if it's going the other way, I could have gotten 4 radical 405 plus 18